Welcome. Today we're talking about how to find the area of a sector. Now first let's review the other area formulas that we've looked at through this playlist. Area of a rectangle was length times width. Area of a parallelogram was base times height. Area of a kite was 1/2 of the product of the diagonals. Area of a trapezoid was the sum of the bases times the height divided by 2. And area of a circle is pi times the radius squared. Now, sectors are just portions of circles, but these are portions bordered by radii, which makes them look like pie pieces. Here in this picture, we have two different sectors actually. We have the gray one that's called the major sector because it's the bigger one, and then we have the orange one that's called the minor sector because it's the smaller one. Now you can have multiple sectors drawn, like more than 2 radii in your circle, splitting off more than 2 sectors. But if you have 2, you can reference them as major and minor. So here we have an example. The dark shaded sector is a quarter circle. We know that already. And we're going to just kind of work through this example to see how we can calculate the area of this sector. Now we know the area of a full circle is pi times radius squared. We did that in the last video. So if the full circle is pi times r squared, then area of the quarter circle should be 1/4 of pi times r squared. And that's exactly what we're going to do. That's how we will find this. So our sector area, since it's a quarter circle, will be 1/4 times pi, and then our radius is 14 squared. As we go through and solve this, we're not going to keep writing the full sector area. We're going to abbreviate that as S. So instead of the big A for area, like we did for the circles and for the full shapes, the S is going to help us remember that we're just looking at a portion of the overall shape. So S for sector area. And 14 squared is 196, so we've filled that in. Then pi times 196 gives us approximately 615.752. And then we do the 1/4 times that number, we get 153.938. So as we round our answer to the nearest tenth, we would have 153.9 square units. I promise we will have a formula you can use for any circle with any sector, but we're just kind of working through how this all works out. Now the shaded sector here is a semicircle, and we want to find the area of the semicircle. Now a semicircle is a half circle, so if the full circle is pi r squared, then the half circle will be 1/2 pi r squared. Now watch out though, remember the only tricky thing that really happened with area of circles was when they gave you the diameter, and we have the diameter here. So as we fill in our sector area, 1/2 pi r is 3, not 6. So make sure you always use half of the diameter as your radius. So 3 squared is 9, and we'll multiply 9 times pi to get 28.274. Multiply that times 1/2 to get 14.137. So our final answer, our sector area is approximately 14.1 square units. Now that's fine if you're told what fraction of the circle is filled up by your sector. 1/6, 1/4, 1/10, that's great. But what if we're given angles? You might be surprised to know we can still use the same process. We just might have to find our own fractions first. So the shaded sector here has a 90-degree angle mark. So we know it's a 90-degree angle. I want to know what fraction of the circle is shaded, because if I know the fraction, then we can use the method we were using before. Hopefully you know by now that a full circle is 360 degrees. If not, then now you do. Full circle is 360 degrees. So the shaded sector, when we want to know what fraction of that circle, we would put the angle we have over 360, and that's going to be our fraction measure. So once we reduce that though, we reduce the 90 actually goes into 360 evenly to make it 1/4. But that is the fraction that we're going to use in the formula. So you might have already noticed the trick I was using here. This is the same quarter circle that we used before. So I'm not surprised, and maybe you're not either, that our fraction ended up being 1/4. But this method will work even if it's a weird degree measure. If you can reduce it, you're welcome to. You don't have to reduce it in our formula we're going to use though. So let's put this all together and look at how we used that fraction in the sector area. So this is what we did before. We said sector area was 1/4 of pi times 14 squared. So that 1/4, that's the fraction of the circle that we want. And of course, the 14 was the radius. So when we look at the order that all of this went in and how everything went put together, overall, our area of a sector, we can use the fraction where we have our angle over 360. You don't have to reduce it. Just put your angle in that spot where the theta symbol is, that Greek letter that looks like a 0 with a line in the middle. That's theta, that's our angle. So your angle over 360 times pi times your radius squared. Let's go ahead and try it. Here's a circle. There's a minor sector outlined in black that shows an 83-degree angle there in the center. If the radius of this circle is 5 units, what is the area of that sector outlined in black? Here's the formula that we just talked about for area of a sector. Remember that theta over 360, we're going to plug in our angle there. So we'll end up with 83 over 360. And of course our radius is 5, so we'll plug in the r equals 5. Then let's just go through and simplify and solve just like we did with our earlier ones. 5 squared is 25. Now the 83 over 360, we're going to find that decimal approximation there. So 83 divided by 360 is 0.23056. Then we just multiply all three of these together. Our big crazy decimal, the pi, and the 25 to get 18.10779. Of course, rounding to the nearest tenth, our final answer is going to be 18.1 square units. That's really all you have to do. Once you know that central angle, you just stick that in the formula, stick your radius in, and as long as you're putting your calculator numbers in the right order, you should be good. Now, what if we wanted to use the same circle and find the area of the major circle? Remember, that's the bigger one. So the minor circle was outlined in black. The major sector is kind of the other one on the other side. So we have some options here. First option we have is to find the area of the minor sector, like we did before with 83 degrees, but then subtract it off of the entire circle. Then we're left with this Pac-Man shape, but we would also be left with that Pac-Man shaped area. If we took off the minor from the circle, then we're left with the major. Now, our second option, though, is to find the central angle for the major sector and then solve it like before. So we find the other angle that wraps us the rest of the way around. We are going to actually solve this out, and I'm going to use method number 2 because that's what I'm personally more comfortable with, but we'll do a second example where we use method 1. So to find what's left, what that major sector's angle is, we'll just take 360, the full circle, and subtract off the 83. We get 277. So here's our arc length, our sector area formula. We're just going to plug that 277 in. So 277 over 360. Now, of course, we do need to get our radius in there, so let's get our 5 in for the 5 squared. And then we'll start working this out. 5 squared is 25. 277 divided by 360 gives us this crazy decimal, but then we'll just multiply those three together and get 60.432. So our final answer for the major sector area would be 60.4 square units. One last example. We're going to find the area of the minor sector, which is shaded slightly pink, and the major sector, which is still white, of the circle that's here. Now we're going to use method 1 here. We're going to find the area of the full circle, then the area of the minor. Use that to let us find the area of the major. So going back to use this original area of the full circle formula, all we need to know is the radius of the circle, which is 7. So we'll plug in that 7. And then we'll just solve that from here. 7 squared is 49. And we throw that in our calculator times pi. We get 153.938. So we'll just kind of set that aside for a minute. We know the area of the entire circle is this 153.9 number. Now we're going to look at the sectors. So remember, our sector formula was theta over 360 equals pi times r squared. Remember, that theta is your central angle, that angle right in the center of the circle. We're going to find the minor sector first, so I'm going to kind of keep this minor s notation so we remember what we're doing. Now, we are labeled there as that minor sector having an angle, a central angle of 100 degrees, so there's our 100 in the formula. And of course, our circle still has a radius of 7, so we'll get that in there. Now we'll just start simplifying and grab our calculator. We know 7 squared is 49. Divide 100 by 360, we get 0.2777 repeating. I went ahead and rounded it to the 8 after a few 7s. Then while that number is in your calculator, your big, long 2 point, all those 7s, just hit times pi times 49, and you should get 42.76057. It keeps going. But that is the area of our minor sector. We'll end up rounding it to the nearest tenth and everything at the very end. We don't want to round it in the middle of our problem, and we still need to find the major sector. So remember, to find the major sector, we just take the full circle and subtract off the minor sector. So we know the full circle was 153.9-ish, and the minor sector was 42.76-ish. So we'll subtract those, and we get 111.178. So when we go ahead and take this to our rounding for final answers, we're going to round everything to the nearest tenth. So our major sector ended up at 111.2 square units, and the minor ended up at 42.8 square units after we rounded everything. So that's kind of the most complicated that these problems will get when you're given the central angle for one sector, but you need to find the area of the other sector. You're going to have to do some kind of subtraction, either subtract the angle to find the major angle, or subtract the area to find the major area. So either way, now you have some tools you can use to find sector areas. How big are those pieces of pie? And you can use the area of the full circle if you need to. Remember, you have that tool in your toolbox. But that's all I have for you today. So thank you for joining me in finding the area of a sector of a circle, and I'll see you next time.